an exponential example. I'm going to make a quick note here. If you're looking at the completed notes, there is a problem between this one and the polynomial example, but I decided that one was harder than I intended it, but I left it in the completed notes in case you wanted to see sort of a harder example where I did solve it graphically. But I did take it out of the notes, and I'm going to stick to the ones that you'll more likely see on the quiz and the test. All right, so an exponential function, right? E raised to the negative x squared. Basically, we're going to do the similar thing to what we did in the last example. So it's a combination of 3.1 and 3.2. All right, so I'm going to find my first derivative and all the information on it, then my second derivative, which is sort of the new part. All right, so if you want to skip past the first derivative, if you're comfortable with the first derivative and kind of fast forward the video until we start to get to the second derivative, you can do that. That's the new stuff in 3.2. All right, so the first derivative, which this one requires, apparently I had used my highlighter last, oops. All right, so the first derivative, which requires my chain rule, it's the e function as is, times the derivative of the inside, which is going to give me a negative 2x. So there's my first derivative. Find the critical values by setting it equal to 0. Again, show the set it equal to 0 step. Remember, the e part is never 0. So the only place I can get a 0 out is the negative 2x, the polynomial part, which divides by 2, that's just going to give me out x equals 0. Alright, so there is my critical value. There's just one. I'll find the critical point once I get done with the testing. Alright, so there's my critical value. Now I'm going to test for increase, decrease. I like the number line, so that's what I'm going to use. So there's my number line. I mark off my stopping point, my critical value. I check to see if my derivative is positive or negative. So negative 1 and positive 1 are always good test points. So again, I'm going up here and checking to see if it's positive or negative. Remember, the e function is always positive. So I don't even have to look at the e function. I really just look at the polynomial. E is always positive, right? Never negative and never 0. So I look at the negative 2x to see if it's going to come out positive or negative. Well, when I plug negative 1 in, the negatives will cancel and leave me with a positive 2. Then it stopped. At 1, it's going to leave me with a negative 2. So that means it moved up, stopped, and then moved down, which tells me this was a maximum at my 0. All right, so now writing that information out. F of x is increasing over negative infinity to 0, decreasing over 0 to infinity, and has a relative max at the point 0, f of 0. So again, I go back to the original function, the e function, plug 0 in. Well, remember when I plug 0 in, it gives e to the 0. Anything to the 0 power is 1. Alright, so 1 is my relative maximum. Right, if you go back up here, plug 0 in, it's going to give me out 1. Alright, so there's all my information on my first derivative. Now the second derivative. So I'm going to undo what I had highlighted there, because I have to use my first derivative to find my second derivative. Alright, so I'm going to go over here and find my second derivative. Alright, my second derivative is a little harder. I have to use the product rule and the chain rule again, because I've got e times the negative 2x. So first function's the e, the negative 2x is the second function. Alright, so it's the first, which is the e term, times the derivative of the second. The second is that negative 2x here. The derivative of negative 2x is just negative 2, plus the second, which is negative 2x, times the derivative of the first, which is the derivative negative e to the negative x squared, times another negative 2x. Alright, I am going to have to set this to 0. I'm going to set it to 0, and then I'm going to clean it up. I'm going to clean it up by factoring. Now, I'm going to factor out two things. Actually, I'm not going to factor out two things. I'm just going to factor out the e term. I think it's the easiest just to factor out the e term. So that's all I'm going to do. So I'm only going to pull the e term out. That's sort of the rule of thumb. And then what's left over? Well, in the first term, I had a negative 2. In the second term, I had a negative 2x times another negative 2x. So negative 2 times negative 2 will give me out a positive 4. X times x will give me a x squared. And so there is my polynomial. All right, so remember, E is never negative. So I kind of ignore the E. It's never going to give me a 0. Only part that's going to give me a 0, possible give me a 0, is the polynomial -2 plus x. And so that's the one I'm going to solve. I'm going to move the 2 over, divide by 4, so I get 1/2. So it's going to be a pretty number, and a lot of times it's not, especially with exponentials and logarithms. So I get plus or minus the square root of 1/2 equals x. And I'm fine if you leave it like that. If you've had classes before where they made you write it out a little nicer, that's plus or minus √2 over 2. But I actually think this is the easier one to work with. It's the easier one to plug in stuff. And so I'm going to leave it √2, square root of 1/2, okay, instead of √2 over 2. But √2 over 2, if you like to be nice and precise, is fine. All right, now the test for concavity. Again, it's just like the test for increase and decrease, except you use the second derivative. So I mark off my 2 possible inflection points. Remember, these are the possible places where it may switch concavity, and most of the time it does. The vast 90% of ours it'll switch. There's a rare case where it doesn't, but 90% of the time it does. All right, so the second derivative is what we're testing. So I'm going to write down my second derivative. Minus second derivative, so second derivative was e to the negative x squared times -2 plus 4x to the second. So I have to look at. Alright, so remember, e is always positive, so it's really the polynomial part I look to see if it's positive or negative. The test points I like are -5, 0 is always a good one, and +5. When I plug +5 and -5 in, the same thing's going to happen. So I just have to plug one of them in, right? Because the square will make the negative a positive. So this is going to come out 25 when I plug 5 in, times 4, so 200, minus 2. Well, 200 minus 2 is going to be positive. So this comes out positive, and that means this comes out positive. When I plug 0 in, I'm left with a -2. Well, that's obviously negative. And so concave up, switched, concave down, switched, concave up. And so there's my results. Now I write them out. F of x is concave up from -infinity to the -√1/2. Also from the +√1/2 to positive infinity. Concave down between the ugly roots. So between the -√1/2 and +√1/2. And it does have inflections. Again, now I'm going to write them out as points. Remember, the y value comes from the original, so I have to go plug this back into the original. And this one is an ugly number. So I plug in the +1/2 back into my original function. To get the inflection point is at square root of 2, and I'm just going to round 2 decimal places. 0.61. Same thing's going to happen at the negative, except it's going to come out the negative. Negative square root of 1/2 comes out -0.61. Right, because there's, oh no, because that positive, sorry. Look at my calculator, right. Positive 0.61. That came out both, it's symmetrical. Alright, there's all my answers. So now I've got everything. The last step is to check my answers graphically. Alright, so again, I'm going to go over here. We're going to graph the original function. The original function was e to the -x squared, so remember that was the original. You probably will have to zoom in. If you look at our numbers, right, our maximum's 1, right? Remember the relative maximum was 1, and our inflection point was at 0.6, which is less than a half, which is slightly bigger than a half. And so more than likely you're going to have to zoom, start with a standard window and zoom in. So I did one zoom. I hit the origin and zoomed in once. All right, and then it has this shape. This is the point 0, 1, which is my critical, right? I got a horizontal tangent, and that's my max. And then use your value key, type in so you can kind of see where it is. Type in, so hit second trace value, and then type in square root of 1/2, and this will check the numbers. And it should be about right here. So it's at square root 1/2, 0.61, and then over here, negative square root 1/2, 0.61. And this one's a little subtle. The concavity part's a little subtle. Again, the increase, decrease should be obvious. increasing up to the 0, 1, decreasing after the 0, 1. There is an asymptote here at y equals 0. Never crosses, right? Never negative. And then the concavity is the little harder part, right? But this piece is concave up. This piece is concave. It should have a slight curve up shape. And then between the roots, it should have that one's a little more obvious that piece is concave down. All right, the tails are a little tougher, but you'll notice that there is a curve. It does concave up. It's sort of like a little piece of concave up. But that is the concave up shape. It is following the concavity. My slopes are getting smaller. You'll notice that I have bigger slopes here, and there's smaller slopes as I move out to the tails, which is what concavity is telling you. It's concave, more or less negative, I guess I should say. Alright, and so there's the check. And that one finishes up. I believe that's the last one where I'm kind of going to go through everything, and now we'll pick up the next video, which we're going to, if we give you some pieces, sketch a possible graph. Alright, so kind of, can we do this part based on our information? Can we graph a function given specific things about its concavity, its derivatives, and stuff like that? Alright, so that's the next video.